Okay, this is 2007, question 1. Before the test revision, the first question was always an equilibrium question. When I converted over to the Smartboard software, this KP value didn't copy. So here's what we'll say. Remember, it's right over left, and so because it's a P, it's the pressure of UO2Cl2, but then that pressure has to be cubed because the stoichiometry becomes the exponents, times the pressure of O2, and that's to the first power, divided by, and remember, pure liquids and pure solids aren't used in calculating equilibrium, over the pressure of the chlorine gas, the pressure of the chlorine gas. And that also has to be cubed. That'll be interesting in a little bit. Okay. When the system is at equilibrium, the partial pressure of the Cl2 is 1.007. So they're actually giving you equilibrium concentrations. So let me just do this. Let's rewrite it down here. Okay, and so we don't really need to do an ice charts. Ice charts are for when they give you initial concentrations, but they're giving you the equilibrium concentration, or sorry, pressure. This is pressure. I'm sorry, let me grab the eraser. That was kind of a stupid mistake. So these are pressures because this is a KP problem. And you don't have to do the ice chart, which is the whole point of my long-winded explanation here, is that because they told you that the equilibrium pressure of this was 1.007, I think, atmospheres. So this is in atmospheres. And they told you that this pressure was 9.734 times 10 to the negative fourth atmospheres. And the first question A is, what is this pressure? And because these are on the same side, you can just use this mole ratio. This tells me, remember, if we didn't know these, we would call this 3x and this x. There has to be 3 times more of this than this, or 1/3 as much of this as this. So the first one's actually pretty easy. What's the partial pressure of the oxygen? Well, it is going to be 1/3, because of the mole ratio, of the pressure of the UO2Cl2. And so if you do that on your calculator, just take that and multiply by third or divide by 3, however you want to get it. And this has 4 sig figs. I got 3.245 times 10 to the negative fourth atmospheres. And you can do that because they're on the same side. If you had one here and one here, because this is, I crossed this other thing out that was over there, but these are going to, because they're on the same side and because they're being formed from this and stuff initially, that mole ratio will be true. Okay, next one, what's the equilibrium concentration? So this is why I wrote this in. Kp was given to you in the problem as the pressure of U2O2Cl2, but because there's a 3, it's cubed, and then times the pressure of the oxygen to the first power, or you can just ignore that. And then it's the pressure of the chlorine gas. Again, notice that the first reactant is not there because it's a solid. And so this is just straight plug and chug. This was given to you. It was 9.734 times 10 to the negative 4 atmosphere. Sorry, we don't use units on this. Even if it has a unit, we drop it. So let me grab the eraser. Just accidentally to turn that on. Okay, and so then times, and we just figured out in A that the pressure here was 3.245 times 10 to the negative fourth. We just did that in A, and then divided by 1.007. That was cubed. So anyways, this was given, this was given, this we just calculated in A, and so the answer ends up being 2.931 times 10 to the negative 13. And even though it would have a unit, because you'd have 4 atmospheres on the top, or atmospheres to the fourth, and atmospheres cubed on the bottom, we're really only interested in the number. This is a very small number, And so that means you have very little on the right and lots on the left. This is interesting. I love this. This is the equation that connects thermal and equilibrium. Girls are not real tough when they're having kids naturally. However you do that, get it off your iron sheet. When you're doing thermal, the R value is 8.314. Again, if you look online at the scoring guidelines, I think that they only have 3 sig figs when this, so 8.31 was, but now the formula sheet has 4, so we're going to use 4 joules per mole K. And then the temperature has to be in Kelvin, so I have to come up here and add 273 to 862, and if I do that, I end up with 1,135 Kelvin. And so 1,135 Kelvin goes in for T. And then ln of the answer for B, which was 2.931 times 10 to the negative 13. Again, remember, if you calculate B wrong, but you use it correctly in C, you'll get full credit. So this was the answer for B. This is a constant. This was given. And then remember, right now we're in joules per mole, but delta G and delta H are almost always given in kilojoules. So just remember, see joules on the top, there's 1,000 joules in a kilojoule. They didn't tell you, but if you do that, I'm going to grab a different color. The only units that don't cancel are kilojoules on the top and moles on the bottom. And again, remember, they're using that mole RXN notation now. And when you do this, you get positive 272 kilojoules per mole. And it's positive, which means this is an endothermic reaction. And that's because Kp is so incredibly small that the backward reaction is favored. And so delta G is going to be positive, non-spontaneous. Okay, state whether the entropy at 862 is positive, negative, or 0. So what I want you to practice is when you're on the AP exam, you have to reason this out first and then write your answer. But the very first thing you should do is answer the question. I'm just going to say this. Delta S naught is positive. Now, I've answered the question. Now I'm going to justify. Here's how you justify it. I'm going to go back because I don't want you to flip back and forth. So basically, here was the equation. So here's what's going on. I'm going to switch colors. We have 3 moles of gas in the reactants, but the products contains 4 moles of gas. And so, so here's your justification. I mean, you don't have to write this down. I'm just writing it down so you can see it. I would justify this by saying, right here in the next sentence, this was just to explain to you, there are 3 moles of gas in the reactants, and 4 moles of gas in the products. Sorry, in the products. So the move this up. So the system is becoming more, is the positive, disorder. Entropy is a measure of disorder. So if it's getting more disordered, delta S would be positive. So system is becoming more disordered, and that's your justification. All right, next question. State whether delta H at 276 is positive, negative, or 0. So the first thing I'm going to do is I'm going to answer the question, which is delta H naught is positive. Always answer the question first. Okay, now I'm going to go down here and explain why. Gators are hell without tartar sauce. I'm going to solve this equation for delta H. So you can see that delta H is equal to delta G plus T delta S. And so here's why we know it's positive. We just calculated this. This is positive 272. This is positive because temperature is always positive, but in this case, it's because absolute zero is the coldest temperature in the universe. If zero is coldest, you can never have a negative temperature. So that's always positive. We just figured out in part D that S is positive. And so if you add two positive numbers together, you get it positive. So here's our justification up here. Delta H is equal to delta G plus T delta S. Delta G, T, and delta S are all positive. So the sum will be positive. Now they can't give an answer because we don't know the value of delta S. We just know that it's positive because the system's becoming more disordered. All right, last one. Okay, interesting. Let's go back to the equation again. U3O8 solid plus 3Cl2 gas goes to 3UO2Cl2 plus O2 gas. Okay, remember now solids. And so here's the deal. Does the mass of the U3O8 in the solid increase, decrease, or remain the same? U3O8 mass increases. Why? If O2 gas is added, Le Chatelier's principle says it doesn't like that you add it. It tries to get rid of it by the equilibrium shifts to the left. Making more U3O8. Now, interesting, we keep telling you solids and liquids do not participate in the equilibrium. In other words, if you added U3O8, the equilibrium would not shift. Nothing would happen. But it does participate in the chemical reaction. So if you speed up this backward reaction, that's what shifting left means. You're going to make more of both of these. When we say it doesn't participate in equilibrium, we just mean that if you add this or remove this, nothing happens to the equilibrium because it doesn't participate in the equilibrium, making it shift, but it still participates in the reaction. Kids have a lot of trouble with that.